Today we would be starting with our advanced session, and the first topic that we are going to start with the window functions. Okay, the first topic is window functions. Okay, before we move on to window functions, let us understand window functions with the help of an example. So let's say I have name, I have age, I have department, and I have salary. Okay, let us first understand the concept and then we'll go to our Airbnb retail project and we will do window functions there. So this is my table name and let's say employees. This is my table name. Let's say employees. Let's say name is Parmeet, age is 23, belonging to finance department, salary is 50,000. Okay, we can take name is Ramesh, 22. Again, he's from finance department, salary is 20,000. Then we have Ram. We have Ram. Okay, whose salary is whose age is let's say 26. He is from sales department and let's say salary is 30,000. And we have Suresh, 27, finance department, salary is 30,000. And we have Trishan, he is again 21, from sales department, salary is 20. Okay. So we have this basic simple data set, okay, where we have 5 rows and we have 2 departments. We have 5 rows and 2 departments, okay. Now if I ask you, can you write a query, since we are already aware about the basics. So if I ask you, can you write a query to find out the average salary of employees within each department. Okay. If I ask you to write a query to find out average salary of the employees within each department, if you have this data set. So can you write it? Can you write it? Can you write a query to find out average salary of employees within each department? So what you would be doing in this case? So you would be going with the group by operations, right? You would be writing a query that, okay, we want to select department name. We want to select department name. I want to find the average salary, right? Average salary from employees table, and you would do group by department, right? So what is the problem with this query? Is there any problem with this query? The problem is that if you see the output of this query, it would be something like this. Department. So there are two unique departments, finance and sales. It will do average of finance salaries. So 50,000. Parmeet has got salary of 50,000. Ramesh got 20,000, and Suresh again belongs to finance department. He got again 3 lakh. Okay, so this is the average salary for the finance department. If I talk about the sales, it would be 30,000, 20,000. Average would be 25,000. But this query is losing the properties of the rows. What do I mean by that? So if you see, we are losing some information in this query. We are losing the name, age, and other type of information, and the query is losing the actual information from the table. So we are losing some properties from this table. So this is one of the scenarios where we could use the window function. Another scenarios would be where we would be using the rank, dance rank functions. So what are those? We will read in a meanwhile. But let us first understand. I want output something like this. I want output something like this. Okay. It should be name, age, department. Okay. And let's say I should get one more column here, average salary. Okay, average salary, and now I should get it finance first, then this, sorry, will be like this, then this finance should come here, okay, followed by sales, data, and the average salary is 123,333 for this, okay, 25,000 and 25,000. So I want something output like this, okay. I want output like this. Is very pretty simple query, so that's where you could achieve it using group by also, but every time it is not possible, okay. If I talk about, if we go in depth about the window functions, the rank, dense rank, percentage, row percent or rank percent, then it would be very difficult for doing using the group by. So let us first understand the syntax of the window functions. What is the syntax of the window function? So syntax would be, first you would be writing select column name 1, comma, then any window function followed by column name 2, then over clause followed by partition by column name 3, order by column name 4, column name 4, and renaming this column as a new column, then we can write from table name. Let us understand this query. What is this query all about? Let me increase the font size, okay. The syntax which I am highlighting in red are fixed. The syntax which I am highlighting in red are the keywords, okay, are the keywords. The syntax which I am highlighting in red are the keywords, okay. Now this window function, this would be the replaceable items, okay. We will study about all the window functions that could be applied. So let us understand this query now. So column name 1 is all the columns that you want to select, list of columns that you want to select. Column name 1 is list of all the columns to be selected, okay. And we have column name 2, okay. It is the list of columns, or it is a column name on which we need to perform aggregated function or ranking function or rank function or window function. We can write or window function, okay. So okay, let me wrap the text. Then we have column name 3, then we have window functions, then we have something known as window function. So here it will come aggregated functions or window functions. So can anyone tell me what are aggregated functions? Can anyone tell me what are the aggregated functions that we already read in our previous classes? Do you all know the aggregated functions? Anyone? What are the aggregated functions that we already read? Yes. So it is average, sum, max, min, count. These all are the aggregated function, right? Then column name 3. Then we have something known as over clause. So that is on which we want to apply those, okay. It will decide on which, what are the operations on the window functions we need to apply. Operations or conditions. What are the conditions for the window functions? So it will decide that, okay, what is the condition or criteria? What is the criteria that you are applying? What is the criteria that you are applying? Okay, this is over clause. Then we have, if you see, we have partition by. Partition by. It is nothing but it is similar to group by. Okay, it is, you can brain map it to group by. It will decide, it will decide on what condition I want to partition or bifurcate or group my table. Group my table. Okay. We'll let us first understand the terminologies and then let us stage we'll see the example. Okay. Then order by is sorting conditions. Okay, on what basis you want to sort and apply the ranking functions or aggregate functions. Then you have column name 3 is on what basis we want to apply a partition. Column name 3 means on what condition you want to apply, on which column you want to apply partition, on which column you want to apply the partition. Then we have column name 4. It tells us that before applying window functions, what order you want to maintain, on which column ordering you want to maintain. Okay. Then we have something known as new column. If you see this, we have the new column. So it is the new column name. It is the new column name. New column name. Okay. Then we have table name. Okay. Name of the table from which we need to select the data. Name of the table from which we need to select the data. Okay. So these are the terminologies, or this is overall idea about the syntax of the window functions. Now if I ask you, can you write a query to find out average salary of employees within each department? Can we write a query to find out average salary of employees within each department? Now using window functions, I will achieve this. How? Let us see. So let's say I want to write a query. Let us write it here. So I am writing, let me increase the font size. Select. First is the keyword select, then column name 1. What column name 1 tell us? List of all columns to be selected. I want to select name, I want to select age, I want to select department, then I want to select salary. Great. We have selected all the columns. If you see, this was our original table and this is the output. This is the output that we need. Okay. Now, if you read a question carefully, they are asking you to find the average salary of employee. So here window function that we are going to apply is average. That is an aggregate function. So see, window functions takes the aggregated functions or any of the window functions. So we are first reading the aggregated functions. So here I can apply average over the column of salary. I want to apply average, okay, to the column salary, then over clause is over. And please note, inside over clause, these all are optional. Partition by, column name, order by, column name, these all are optional. Okay, but in this case we want to find the average salary on basis of department. Okay, we want this average salary within each department. So that's where I would use partition by department. Okay, I want to partition by department. That's it. Then order by column name, I don't want to order it as of now. I told you that these two conditions inside the over clause is optional. Okay. As is a keyword, And let's say I will give a new column name to this query, that is average underscore salary. Okay, now from what table we are selecting this data? From employees. That's it. That's it. The query is done. Okay. If you write this query, what it will do, it will give you output like this. So let us see now working of the, let us now see the working of the partition by. Let me write here another sheet, working of partition by. See, I could have directly shown you over the SQL, but let us first understand the aspect, what it is all about. So let's say this is my table. Okay, the moment you apply partition by, so see here I would apply partition by, let's say department. So internally what it is doing, internally what is the working, what is the working. So it will take this original table, this SQL will take the original table, okay, and it will see that okay, you are doing partition by department. So it will check how many unique values are there inside the department. There are two unique values inside the department. We have two departments, finance and sales. So what it will do, it will temporarily create a two database, two tables. It will temporarily create two tables. In one table, it will place, screen is not visible. Okay, let me again share. Hold on. If screen not visible, let me please again share. Are you able to see it? Yes, no? Are you able to see the screen? Guys, can anyone please confirm? Okay.
Visible, sir.
Okay, thank you. So the moment you write the partition by, so you would see that okay, on the basis of department, it will check how many unique values I have. Internally, this partition by will separate into two different tables. Now, in the first table, it will maintain all the finance related data. Okay, it will maintain all the finance related data. Then in the second table, you would see in the second table you would see it will maintain all the sales related data. Okay, the moment I apply partition by, it will do like this. Okay, let's say if I do order also, if I do order by name, then it will arrange those on the basis of name, or order by age. If I do order by age, it will then arrange this table, it will then arrange this table on basis of age. Then it will see what aggregate function you are trying to apply. It will see what aggregate function you are trying to apply. You are applying average salary, you are applying average of salary. So it will try to calculate the average of this table, average of each this column. It will try to apply the average of this column. Okay, and that's where you would get this kind of output. Let me write 1 2 3 3 3 3. Okay, here you would get 25,000, and here also you would get averages 25. Then it will go and see that okay, what is the column name that you are renaming it. So here we are renaming it to average salary. So that's where it will append a new column here. It will rename it to average salary. Okay, average salary. And at the end you will get the combined output. At the end you will get a union of this. Getting, guys? So this is the working of the window functions partition by, window functions partition by. Okay, now if we take the same example, let us first understand all the window functions today, then we'll go to a demo of the window functions. Okay, now if we take a same example, and here let us take the same table, let us take the same table. Okay. And let us add two more rows to this Let us add 2 more rows. Okay, now I am writing here Aniket, age is 22, he is from finance department and salary is again 3 lakh. Okay, then we have Abhishek, 23, finance, and again the salary is 20,000. Now this is our employees table. This is our employees table. Now the problem statement is we need to find find the rank of employees within each department. Find the rank of employees within each department on the basis of their salary. Okay, so the employee which has the highest salary should be rank 1, and the employee which has the lowest salary should have the lowest rank. Okay, so what is the output that I need? Let us first understand the output. So I want something like this. Okay, which is the highest salary in the finance department? It is Suresh. Let us write Suresh. Okay, then followed by Aniket. Let us write Aniket. Okay, then we can write Parmeet. We have Parmeet. Then in the finance department again we have Ramesh, and then we have Abhishek. Okay, so these are the 5 records belonging to the finance department. Now let us go and see the sales. In the sales I have 30,000 and Trishan is 20,000. Okay, so what I want here is I want to apply a rank. I want to apply a rank here. So what would be the ranking of this? This is the top rank. If you notice this, let me color it in different way. Now if you notice this should be rank 1, this should be rank 2, this should be rank this should be rank 1 because both are the ties. Then this has the lowest salary, this has the second rank, then this is the third rank, this is the third rank. Okay, so this is inside the finance department. This rank is inside the finance department. Now I want this ranking. I want ranking in the sales department. So again it should reset and start with 1. So in sales Ram has the highest salary, so the rank is 1. Trishan is second highest salary, the rank is 2. I want something like this. Okay, so these are the rank that I am trying to assign. Now how to define that? Again we would use the concept of the window functions. Guys, please understand this query. Okay, it is tricky, somewhat tricky. It is somewhat tricky. Okay, okay, let us write that query here. Here I would write a query. We would first write select. What are the column names that you want to select? I want to select name, I want to select age, I want to select department, I want to select salary. Okay, then I would apply a window function that is rank. You would see I have applied a window function that is a rank. Okay, that is rank over. I want to find rank for each department, that is partition by department, and I want to order by salary, salary descending, order by salary descending, as new column as let's say rank, we'll give it as rank. Okay, from table name is employees, so this is our salary, this is our query. Okay, and it should give me the rank table. Okay, so this is what we are expecting, this is our expected rank, this is what I want, expected. Okay, I'm looking for output something like this, but writing this query, I will get output like this, actual rank. Okay, what I'll get output, let me just format it. So I'll get output something like this: 1, 1, then it would be 3, then it would be 4, then it would be 4. And let's say if I have one more record, let us add one more record as Shyam, and 25. Again, he's from finance and his salary is 15,000. To understand more in a more better way, let us add one more record here. So you would see here I have Shyam and his 25. He is from finance department. His salary is 15,000. Okay, his rank, expected rank, we are looking for 4, but actually his rank would be 6. Actually his rank would be 6. So now you would be wondering why. Using this query, why we are getting output like this and why not like this? So this is the working of the rank. What rank do? Whenever there are ties, it will skip the rank. Whenever there are ties in the values, it will skip the rank. Okay, what is the row number for this? 1, 2, 3, 4, 5, 6. Okay, so there are 6 rows for finance department. You would see these 2 rows has ties, so that's where it will go to the row number and see that okay, this row number 2, so I'll skip the rank. Okay, so it has skipped one rank. It has skipped the rank. Okay, now 50,000 we have only one record, so no issues. After that we have 20,000 and 20,000. So again these 2 rows would be assigned the same rank, and here you would see that there is a skip of 1. It will go to this row, it will check its row number and add 1. Okay, if there are 3 rows, so let's say if there were 3 rows, 4, 4, 4, then the next one would be 7. If there was one more row, 4, 4, 4, so it will go back to its previous row, check its row number and add it by 1. Okay, so this is the working of the rank. This is how ranks will work. Okay, now the question arises, then how would I get my actual rank, right? My expected rank. How I want this type of output. So how to get that? How to get that? So this is the working of rank. This is one of the window functions. Now we'll look into the another aspect. Let me copy this. Let me copy this. Now, if you need this, then there is a function. There is a function which is known as dance rank. DENSE underscore rank. There is a function which is known as dance rank. Using dance rank, you will get this type of output. So this output would be of dance rank. This would be output of dance rank. And this would be output of rank. This would be output of rank. Okay. So what is difference between rank and dance rank? So whenever there are ties in the values on which we are calculating the rank would skip. Rank would be skipped. Whereas dance rank, there would be no skip in the values. There would be no skip in the values. This is one of the interview questions. I hope this is clear. We did nothing, just we changed the window function to dance rank and we'll get this type of output. But when we were using the rank function, there were skip in the values. There were skip in the values. Okay. Now there's another function. Let us copy this. Let us copy this. Okay. First we'll understand everything in Excel. Okay, let us first understand the theoretical aspect and then we can directly go to the query. Okay. Now let's say if I ask you, can you assign a row number to each of these columns? Now I want row number. So now the problem statement is you want dance rank, we also want rank, we also want row number. We want all the 3 things. Okay, in a single query we want all the 3 things. So what is the row number for this? 1, 2, 3, 4, 5, 6, 7, 8. So I want row number like this. I want that a row number should be assigned to each of this. Okay, I want a row number to be assigned. So what we'll do, we want to first calculate the dance rank. We already have this. Okay, then second column they need is rank. So you will write rank function. Let me color it. Rank function. Then over partition by department, order by salary, descending as rank. Okay, this would be my second column, which would be created. Third column would be row number. Third column would be row number. This is my partition. This is my window function. This is my window function. Okay, and if you see here, the row numbers are in the increasing order and they are not doing any partitioning. So see, row numbers are not changing when the department is changing. When department is changing, the row numbers are not changing. So I don't want to apply any partition on this. So that's where I will write a over clause and leave it blank. So I told you that inside over clause, everything is temporary. Okay, so that's where I have created a row number. And this is a table name. Okay, so here I am leaving it blank because I don't want to do anything. Just assign a row number to all the columns, all the values. Okay, all the rows without partitioning on the basis of department. So this is row number. This is row number window function without partition. Row number window function without partition. Okay, let's say you got the same table again and you got the requirement. Now you want row number without partition. This is without partition, and now you need one more column here, that is row number with partition. You want one more column here, that is row number with partition. Okay, let me increase. So here I want row number with partition. Okay, so now if you see this, the output of this, it would assign a row number to this finance department. The moment the department changes, it will change its row number and it will give 1 and 2. It will give 1 and 2. So here this is row number with partition. So how to do that? So this is row number without partition column, taking the same query again, comma, and let me decrease the font size. Okay, yes, and let us write down now again row number over, and I want to do partition by department. Okay, this is row number with partition. Okay guys, are we good with this? Okay, so now till now we learned the four functions. Okay, what we saw in the first we saw aggregate function. You could also apply min, max if you want a maximum salary, minimum salary. Okay, you want to count how many records are there in each of this finance department and the sales department. So that's where you could use the aggregate function as count. Now this is row number. Let me write it with partition. I would push this over my GitHub repository, so don't worry about this. Let us focus on understanding everything. Okay. Now next thing in this is that there is one more function. That I could write as, let me remove all this. We are now interested in. There is one more percentile underscore rank. Okay, this is one of the window function. It would just return the percentiles, what we have learned in the pandas. Okay, pandas describe method, it would return the percentile. Similar way, it will return the percentiles. Okay, percentile rank, percentile as percentile underscore rank. Okay, this would return the percentile rank. Let me remove this. two columns. So here it would be percentile underscore rank, and it will try to calculate the percentiles. It will try to calculate the percentiles for within each column. So let's say if I talk about the sales, it is pretty easy. This is the 0th percentile and this is the 100th percentile. So you will get 0 and 1. Okay, first row would be always be a 0th percentile. It will be the 100th percentile, and let's say it could be 20th percentile, it could be 20th percentile, it could be 40th percentile, it could be 40th percentile. Okay, and then it could be 100th percentile. So it will just assign a percentile rank. It is not used that much, but at least you should know that okay, we have some function known as percentile rank. We have a function, window function known as the percentile rank, which will give us the percentiles. Okay. Next window function, which is important. Let's say in the same problem statement, if I ask you interview question again, I want to extract Control C. Interview question. Now you want to find the employees with highest salary in each department. Okay. Statement is now changing. We want to find the employees with highest salary in each department. Okay. So in this, the highest salary is for Suresh and Aniket, whereas for sales, the highest salary is Ram. So output would be something like this. So we don't want this. So Parmeet and this thing should not appear. Yes, that is one of the way to do it. That is one of the way to do it. We'll delete. Okay. We would delete this. Delete. So there are two ways. There are two ways to do it. Okay. We don't need dense. We don't need rank. We don't need percentile rank. Control Z. Okay. We don't need this percentile rank also. Okay. So what I'll write. So the query. There are two ways to do it. There are two ways to do it. You first calculated the rank. You first calculated the dense rank. Okay. And here you can apply a condition where dense rank equals to 1. Okay. So you will get output like this. You will get output like this. Okay. This is one way. This is one way, pretty simple. Another way is you have a function. You have a window function. Again, we have a window functions. So that window function is known as the first value. That window function is known as the first value. First underscore value. FIRST underscore value. First underscore value. Okay. We can define it as top and no need of this. No need of this. So first value. Okay. We have a window function known as first value. Getting, guys? Two ways. There are two ways to achieve this. This is another way. Okay. Are we good? Okay. So this covers our one more window function, that is first value. Okay. In similar manner, if I ask you, can you, okay, first value, you were able to do it. First value, you were able to do it. Okay. By using rank equals to 1. But how about if I ask you, that now I want to find out the employees with lowest salary in each department. So what is the lowest salary here? What is the lowest salary for finance? If we go and check, the lowest salary is for Ramesh. So I should get output here as Ramesh 22, finance 20,000. Okay, I should get output like this. Then second, we don't need dance rank at this point in time. We don't need dance rank, right? Let us insert one more value row. Okay. Okay. So now here I would need, in sales department, I would need Trishan because it has the lowest salary. Okay, that's it. That's it. So can anyone tell me how to achieve this? How to achieve this? Okay. So now what you can do is simply you can achieve this using again dance rank. You can again achieve it using dance rank. How? So see here we are doing partition by department, order by salary. So what you can do, it is descending. You can just make it ascending. You can just make it ascending. The moment you change it to ascending, the rank will change. The moment I change this to ascending, let us go back to our dance rank function. Okay, if you notice here, I have made this dance rank. If you see here, dance rank here salary is ascending. Sorry, descending. If I make this salary as if I make this salary as ascending, let us copy here. As ascending, so that's where you would now see that the order is changed. Order is changed. Okay, so first it will come. Sham will come first. He would get rank 1. Then Abhishek would come second. He would get rank 2. Then Ramesh would come again second. He would get rank 2. Okay. Then Parmeet would come at the rank 3. Okay. Then Aniket would come rank 4. And Suresh would become rank 4, right? Because what we are doing, we have changed the order. That was you partition by department, but you need to order by salary in ascending order. Order by salary in ascending order. So what it did inside each partition, it has arranged these rows on the basis of salary in ascending order, and at last it is assigning a rank. At last it is assigning a rank. Getting, guys? Yes. If you see here, this is 1, this is 2. Okay, so now in this again you could select the query is the same, and again you could select where rank equals to 1. So the moment you do where rank equals to 1, you will get the top values. So you will get the records with the lowest salary. You will get the records with lowest salary. You will get the records with lowest salary. Okay, this was the first way where I could do order by salary ascending dance rank from employees where dance rank equals to 1. Second, I have a window function that is a last value. Okay, last value. So we keep the same query as it is, and just though the order by salary is descending, but we have just changed the window function to last value. That's it. Okay, so we are done with almost rank, aggregated functions, rank, dance rank, row number, percentile rank, first value, last value. Great. Let us see two more functions. Now let's say I have a sales data set. Okay, I have a sales data set, and this is my month and my sales. Okay, value. Month by month, month on month sales value. Let's say I have January month, February month, March, April, May, June, July, August, September, October, November, and December. Okay, let us take the sales value as 10,000, and let us do this plus this, creating some random data for you. Okay, now for few of them we can do minus minus 0.2 minus 40% hike, and let us do 50% sales has been decreased. Okay, now if you see here, This is my sales data. Okay, this is my sales data, the dummy sales data that I have created, and I am interested in knowing my month on month sales, where I'm increasing my sales or not. Okay, I am interested in knowing my month on month sales. I'm interested in knowing my month on month sales. So what I want, if you see the February month, I want to compare it with the January month and want to find out whether my sale is increased or decreased. So you can clearly see that the sales is increased. Okay, if I talk about May month and if you compare it with the April month, the sale is decreased. The sale is decreased. So how you would find how I'm getting this, whether the sale is increased or not? So basic calculation that you would be thinking in your brain is that, okay, somehow if I could get this value here, somehow if I could get these values here, somehow I could get the previous value here, and I could write it here, so I can easily calculate, right? Can I get something like this? Can I get something like this? Let me write it here. Let us not disturb the original table. So I want something output like this, right? And I can get something like this, and I would call it as previous month sale, right? If I get something like this, then it would be very easy for me to calculate the columns, right? It would be very easy for me to calculate. But how to bring this? How to bring these values, previous month values, into this current previous month value to the current month? Is there any way to do this? Is there any way to do this? This value, it would be NN because previous month data is not present. So that's where if I want to calculate that whether my sales is profitable or loss, it is profitable or loss. Okay, we are not calculating the percentage, just a value. So here let's say it would be same, so it will be NA. We are not interested in January month because no previous month sale is available. So if you see here 11,000 minus 10,000, that's where you are making a profit. Okay, if you see here, you are making loss. You are making loss. So in similar manner, I want to get for all the months. So can I get this? Can I get this? So you would see here, we are interested in knowing that, okay, which month we did not do well, why there is loss. We want to analyze. So these 3 months we want to analyze from the data. Okay, but to achieve this, we have to achieve this thing. So how to get this? How to get this? So this can be achieved again using the window function. How? Let us see. Let me write the query here. Okay. So this can be achieved using window function. So that's where we would select what are the columns that you want to select. Month. I want to select sales value. Okay. Then there is a window function known as lag. We'll talk about it lag. I want to create a lag on sales value. I want to create a lag on sales value. Okay. So, and over. Is there any partitioning that you want? No, I don't want to do it. No partitioning, nothing. And I just want to rename it as previous month sale from table name is sales. That's it. Okay. So you would see that, okay, I have applied a window function, say lag. Lag is a window function over the column sales value. Over the column sales value. Okay. This lag sales value over as previous month sale would yield me output like this. It would give me output like this. Okay. Lag, if you want to know about lag consists of 3 parameters. Lag has 3 parameters. Okay. The first parameter is that it will take column name. It will take column name. Okay, so that's where you would see that this is the first parameter where it is taking a column name. Second parameter is offset. What does it mean? How many number of rows you want to skip? and by default it is by default it is 1. If you see here, we are skipping one row. Okay, we are shifting it by one row. We are shifting it by one row. Okay, so by default it is 1. So second is optional. Third is, do you want to replace the null values with any default? Okay, so here if you see, do I want to replace this by any default? Yes, no, that also we can do. That also we can do. So let us see all the three things here. Let us see all the three parameters here. Okay, so now I am writing a same query. I'll take the same query and I'll write it here. Okay, this is my previous month sale. Let me just decrease the length. Okay, this is my previous month sale with a lag of 1. Okay, now if you see, I'm writing again lag function, sales value with two parameters. I am doing lag of 2 over as previous month sale lag 2. This is lag of 2. Then third column I am trying to create again over sales value. I am creating a lag of 3 and giving the third parameter, replacing all the null values with 0 over this as previous month sale, previous month lag 3. Okay, so this is my query. This is my query that I am trying to write it, and the output would be something like this. So first output would be like this. This is lag of 1. The column name is previous month sale lag 1. Okay, the column name that we have created, format painter. Okay, let me wrap the text. Yes, now another column is previous month's lag of 2. If you see here, we have passed two parameters with lag of 2. Lag column name comma 2. So that is a lag of 2. That is lag of 2. So I'll shift the values by 2. Shift the values by 2. Okay. Started by here. And okay. So this is a shift of 2. This is a shift of 2 that we are trying to create. Okay. Now last one is previous month sale lag 3 with default zeros. Lag 3 with default zeros. Okay, so I'll copy this, Control V, and now ideally it should be NaN, NaN, NaN. But if you see, we have the third parameter telling that replace NaN with zeros, so I'll get output like this. Okay guys, getting? Yes, no? Are we good? Okay, so this is the lag function. This is the lag function. Okay, I have written all the queries here, the same queries you could run over the SQL. We would, if we get time, we'll go to demo also, but it is very necessary for us to first understand the concepts. The concepts are very important. Okay, now there is opposite of lag, that is a lead function, which is the opposite. Just opposite of the lead is just opposite of lag is lead. Okay, again I'll take the same value. Okay, what this lead function will do, we using this function we can extract the next month sales value. We can extract the next month sales value. So let's say now I need next month sales value. Next month, what was the sales value next? So this was my next month sales value, so this I want it as up. Okay, let me hit this value. Okay, and you can see here we have NN now. Okay, this is lag of 1, this is lag of 1, right? I can also create a lag of 2. I can also create a lag of 2, right? So what I can do is I can do like this. Then this is my NN, and this is my next month sale value. Again, this is my next month sales value with lag of 2. Sorry, it is lead of 1. My bad. It is lead of 2. Okay, it is lead of 2. Now if I want a lead of 3, again I can write this next month's sale value. We'll copy this and we'll get a lead of 3, and we can replace those also with zeros and then okay. Did I do something wrong? Okay, this value is missing here. Okay, so in similar manner we can get the same output and we could create this thing. Okay, the query is same, lead will also take 3 parameters, so again I can write select month comma sales underscore value comma, I can write lead of sales underscore value over, I don't want to write anything, as next month sale value, let's say with a lead of 1, then lead of sales underscore value, okay, comma with a lead of 2 over as next month sale value 2, lead of 2, then third one sales value comma 3, and I want to replace defaults with 0 as next month sale value 3. Okay, and table name from employees, getting guys, can you please go on mute, request you to go on mute. Okay, so this way we could create the lead and the lag function. So till now we have read almost 8 window functions. If you see, we have learned rank, dense rank, row number with partition, without partition, percentile rank, first value, last value, lag function, lead function. Okay, so guys, this was all about the ranking functions. Let me just save this. I will just push this. Entile is also there, we can bucket that, but let us first understand this. There is an entile also, and let me just save this. Okay, let me just tell you entile also if you are interested in learning entile. So entile is nothing but it will try to create a buckets. I'll show you in a demo how to create the entiles. I would show you in a demo how to create a entiles. Okay, cumulative distributions. Okay, so see, Pravesh, there are many functions, there are many rank functions. Okay, so we cannot, what this cumulative distribution will do, that represents the percent of employees. Let's say if I want to calculate the cumulative distribution within a group of values, so that's where we can use this cumulative distribution. But these are the main functions that we use. Okay. Okay, so we'll cover more as we move ahead. Move ahead, we'll cover more. So see, there are many things. Apart from this. If I talk about, there are variance also. There's count, average, max, mean, standard deviation also. That also we can calculate. Okay. We'll see over the example how to calculate the cumulative distribution and other things. Let me now go to the SQL server. and show you their demo for window functions. So let me know once my screen is visible. Is my SQL workbench visible? Are you able to see the screen? No? Okay, let me stop sharing. And again, let me share the screen. Now, is it visible? I think you need to again, let me share my complete screen then. I guess I have to share my complete screen, then only yes, it came but gone. Okay, it came. Okay, let me again share it. Now, Abhishek, Aniket. Let me do once my screen is visible, guys. Okay, so now it's visible. So let us try to do, you were telling something before, cumulative distribution. Yep. So Abhishek, there are two more functions. There's antile and cumulative distribution that we will cover over the practical part. That we would cover over the practical part. Okay. Okay. So let us again go back to our same example. Uh, Black screen in right top corner. I don't know what you are trying to say. Is it not visible, guys? You can rejoin again if it is not visible. If it is not visible, then you can rejoin again. Okay. So my question is, let us now take the example, first simple example. Let us use test. Okay. And in this, let us see select star from I'll take the data set as employees. Okay, employee. So I have this data set. If you see, I have this data set. Okay, simple data set. In this, let us first find the average of average salary within each department. Find the average salary within each department. Select, I can do name, age, department. I can write salary. I can do average of salary. I can write over clause, partition by department as average salary. Okay, from table name employees. Oh, so you can see that for finance department, this is our average salary. If you calculate all these things, 50,000 plus 40,000 is 90,000, 90,000 plus 30,000 is 120 plus 14500. Okay. So it is 134,500 divided by number of records. So you will get something average salary like this. Okay. This is how you are getting. If you see the sales department 30,000 plus 20,000 divided by 2, we are getting 25,000. Okay. Similarly, we can find the max min count. Okay. And that's a total also. Max salary minimum salary and count of employees in each department. Let us calculate all the things. Let us calculate all the things. So here I am doing select name, age. Okay, if you don't want to write like this, you can write e dot star. Let us select all the columns. Okay, I want to get minimum. First, let us calculate the minimum salary over. I want to calculate partition by department. Partition by department as minimum salary. Okay, then let us calculate the maximum salary. Maximum salary over partition by department as max salary. Okay, then let us count number of employees over working in each department. Working in each department as number of employees working in each department. Okay, count of, let's say I would say name, count name. Okay, from table name is employees E, because I'm doing selecting all the columns. What is the error? It is telling unknown column department, so that is E dot department, E dot department, E dot department, and E dot salary, E dot salary, and E dot name. Department in window function. Is the spelling wrong? Unknown column E dot department in window functions. Okay, it is not allowing me to select, is it? Trying to see that. Okay, let us try first this way, normal way, then we'll see this way. Name, age, department, salary. Okay. Age is not there. How come? Age is there. Select name, age, department, salary. Unknown column age in the field list. Select name, age, department, salary, minimum salary. Over partition by this as minimum salary, maximum salary over partition by this as max salary. No, department, that is okay. That is okay. It doesn't matter. It doesn't matter why it is giving. Oh my God, yes. So I have I have choose the wrong table name. So that's why I'm getting that error. It should be employee. It should be employee. Okay. That's what I was saying, that E dot star should work. And let us see, it is working, E dot star. So it works. So let us see now minimum salary in the finance department. Let me close the output. So see, minimum salary is 14,500 in finance. So that's where you are seeing minimum salary. Maximum salary, minimum salary in sales is 20,000. That's where you are getting 20,000. Maximum salary is 50,000 and minimum in sales is 30,000. And see, you are getting the number of employees also. How many number of employees are there? Okay. You can also calculate this sum. Let us also calculate the sum of salary. So you would get total salary in each department, partition by department as total salary that you are giving to each department. total salary within each department. So you would see that this is the total salary that you are trying to give. Okay, so this much amount you are spending in finance department and 50,000 you are spending in sales department. So this 13,000 1 lakh 34,500 is bifurcated this way, and you will see 50,000 is bifurcated in 30,000 and 20,000. Okay, salary count and let's say total salary in each department. Okay, so this was all about the aggregated functions. Let us now move on to the window functions like rank and dense rank. Now I am interested in find the rank of employees within each department on the basis of salary. Okay, so how you would find select e dot star comma, I would get a rank function over, I can do partition by department, order by salary as descending as rank. Okay, let us calculate the dense rank over partition by department, order by salary descending as dense underscore rank. Okay, as dense underscore rank. So we have created rank dense rank from table name is employee. Let us see. Okay, employee. What is the year now? My bad. Unknown column salary spelling is wrong. So see, if you see here rank and dense rank. So see, rank is skipping the values. It is skipping the ranks when there are ties. So rank function will skip when there are ties, whereas dense rank would not skip. So see, after this 4 and 4, there is tie. It is row number 5, so that's where you are getting row number 6. Whereas dense rank would not skip. Dense rank would not skip. Okay. Now find the row number. Okay, row number with and without partition. Okay, before that let us also calculate the find the rank of employees within each department, rank and percent rank. Let us also cover here percent rank. Let us cover percent rank. So here I write percent rank, percent underscore rank over partition by department, partition by department, order by salary. Okay, descending as percent underscore rank. Okay, what is the error? Percent. It is comma. Okay. So see, percent rank, how we are getting. This is 0th percentile, this is 20th percentile, this is 60th percentile, 100th percentile. Sales 0th percentile, 100th percentile. Okay, there is a formula to calculate the percentile rank. You can go to Google and search how the percentile rank is calculated. We are not going into that formula. Now let us find the row number with and without partition. So let's let e dot star. Okay, we'll write row number. We are trying to assign the row number to each of these rows as row number without partition, row number. You want to see the distribution of the records, how your records are distributed, then percentile rank is important. Partition by department, row number with partition from employee E. Okay, partition spelling is wrong. Partition by department, row number without partition, row number with partition. Okay, so that's where when I'll run this employee spelling is wrong. Okay, so you would see now, if you focus on this, the row number without partition and with partition, row number without partition and with partition. So you can see that how the row numbers are changing, how the row numbers are changing in without partition. Why it is giving unordered? Because of this. Okay, because of this. If I arrange this, so you would see that the row numbers. Okay, if I arrange on basis of finance, you would see that the row numbers are different. Okay guys, are we good? Okay, so pretty simple. We have covered row number with and without partition. Let me please hold on for a second. Okay, now let us find the find the employees with highest value, highest salary. Let us find the employees with highest salary. First way, okay, first method. First method. What is the first method? I will select e dot star, comma, I'll select dense rank function over, I would do partition by department, okay, and then I'll do order by salary descending as dense underscore rank, okay, and here I will do order by from employee where dense underscore rank is equals to 1. Okay. What is the error? I have to go and check dance rank over partition by this. Guys, can you please go on mute? Please go on mute. So right now, if you see here,
Sir,
I'm not
I
able to
think
select this.
I think sir dance rank is not in our table already. That's why it is we have to create view or setting.
Yes, yes, that's what I was about to tell you that. Okay, so if you see here, if you see here, if you see here, employee, okay, we are runtime creating this dance rank. We are runtime creating this dance rank. So what you can do is you can either create a view here. We are not discussing about the city. Let us create view here. Create view. Let's say temporary uh, as okay this, and then we can run this, and then you can apply select star from temp employee rank underscore rank where dance underscore rank is equals to 1. Okay, I think the spelling is incorrect, where dance rank is equals to 1. Okay, so you are getting Ramesh and Suresh, but this is not the right way. This is not the right way to do it. Okay, because this and views are also not the right approach to do it. So we would use a function that is a first value. Let us use the first value and try to see the output. So what I'll do, I'll replace this as first underscore value over partition by this. So this is the top from employee. Why first value is not coming? Is it? Yeah, there are different ways to achieve this. There are different ways to achieve this. So here we are getting a first value. Okay. Here we are getting a first value but I want a single record, so that's where I have to go back and look. So if I write last value also, then it will give me the last value of this finance record. Okay, so we'll approach this problem. We will approach this problem using CTEs. So let me tell you what are CTEs. So if I write last value here, so you would see I'm getting last value. Column is added. A column last value is added. Okay. So here a column is added as last value. So I'll go back and check this, but you can do it via CTEs. Let us learn CTEs then. What are CTEs? Okay, so there are few things about CTEs. So CTEs are common table expressions. They are common table expressions. They are common table expressions. Okay. After that, we'll again come back to lag and lead. But to solve this, let us first understand the cities. Cities are common table expression and their syntax is something like this. Syntax is you will write with temporary table, any table name, any table name as, then followed by query, okay, and that would be followed by another query, followed by another query. Okay, so this is a syntax. This is a syntax with query and followed by another query. These are cities. They are common table expressions. So they are temporary or virtual tables. Virtual tables. They are temporary or virtual tables. Okay. So you might ask, what is difference between the CTEs and views? Both are temporary table, both are virtual tables, both are virtual or temporary tables, but but the life of CTE is within the query. Once the query is executed, the temporary table is deleted automatically, whereas whereas life of view whereas the life of view is till we explicitly drop it, till we explicitly drop it. You have to drop the views. Okay, so then the question arises, when should I use CTE and when should I use view? So CTEs are used when you need the query only once, whereas views are used when the is needed query or temporary table is needed again and again. Okay, so that you need to decide. So like in our case where we were finding the uh, top employees within each department. Okay, we will do it using find the highest find the employees within each department with highest salary. So we would achieve this using cities. How? First is with temporary table, any table name. You can write employee temporary table as, followed by query. We can write a query, select e dot star comma. We were calculating the dense rank. Let us calculate the dense rank over. We will calculate partition by, let's say, department. Okay, order by, salary ascending, and let's say this is a dense rank, or you can give anything, top or ranks. Just give ranks. Okay, as ranks from employee E. Okay, this is our query, basic query what we wrote. Let me write it here again. So see the output of this query. It's just we are assigning the rank. Okay, this query I am saving inside a temporary table, that is CTEs. This query I am saving inside temporary tables, that is a CTE. Okay, if I write here another query, what is the syntax? What is the syntax of CTE? Let us go up and see. With table name as, with table name as query followed by another query. with table name as query followed by another query. Now here if I do select star from emp underscore temp, the output would be same. It's just the ranks are now saved in this table. Okay, it's just the rank are now being saved in the table. Okay, so what we were doing earlier above, why our here what we were doing, we were runtime creating a column, and on the same column we were applying a filter. So you cannot do okay. So when you create a runtime column, and on the same column if you want to apply the filters or any other operations, then it is not possible to achieve it. You can use CTEs or views. Okay, Abhishek, I'll tell you. Hold on. So it is select star from employee table. Okay. Now if I again write here select star from emp temp, if I again run this query, okay, so you would see that I will get an error. See, I'm getting an error. It is telling that boss emp temp doesn't exist. Why? Because the life of this emp temp is within the query. After that you cannot use it. Whereas the views, you have a separate place where views can be stored. See, if I create a view, let me refresh it. So see, we have created a view. So see, it is stored here. So its life exists till the time we explicitly delete it. Now in this operation, I want to select all the rows from temp where ranks equals to 1. So see, I'm getting all the records from each department who have the highest salary. Okay, it should be descending, my bad. Okay, so see, so Ramesh from finance department is having the highest salary, whereas Dipesh from sales department is having the highest salary. Okay, if I want to find the lowest salary, same thing can be achieved. Find the employees within each department with the lowest salary. That's it. You need to just change it to ASC. So see, Trishan from finance department have the lowest salary, whereas Pradeep from the sales department have the lowest salary. So this is all about the CTEs. Okay. So we have covered CTEs also. Let us see the lag and lead function. So we would see select star from sales. Okay, I have this data set. Let us calculate sales. Find the percent increase or decrease in sales month on month basis. How would I do that? Select month sales underscore value. Yes, Abhishek, there are various ways to do that, to achieve this. Comma, lag of sales value, okay, from sales. So see, we have created a over as previous month sales. We have created a lag. Now in the same query, I want to calculate the percent increase or percent decrease. So how would I get this? So let's say if I want to calculate for February month, what is the percentage increase or decrease? So the formula would be 11,000 minus 10,000. Okay, 11,000 minus 10,000 divided by 10,000 into 100. So it will give me how much percentage increase or decrease is there. So if I write the same thing here, if you see here I am writing sales value sales value minus previous month sales. Okay, sales value minus previous month sales divide by previous month sales into 100. Okay, and I'll write it as percent underscore increase or decrease. If I run this query, I'll get an error. Can anyone tell me why? See, I am running this query, I am getting an error. Why? Again, the same thing what we discussed above. What I told you here, if you see here, when you create a runtime column and on the same column, if you apply any filters or any other operation, then it is not possible operation, then you would get an error. Yes, then you would get an error. Okay. How to achieve it? To achieve it, you can use CTEs or views. So that's where we want to create this column, but we are performing the operations on this runtime column. So that's where we are getting an error. So what I'll do is I'll remove this. Okay. I would create a CTE over this. Let us create the CTE with temporary sales as, and I want to write this inside brackets. Now the column is saved in the temporary sales. Now let us do select star comma this from temp sales. So see, now I am getting the percentage increase or decrease. So see, here our sales value is decreased. If you see here, our sales value is decreased by 4%, whereas in month of June our sales value is decreased by 25%. By 25%. Getting, guys? Now, let's say if you want to get a lead. So similarly, you can use the same thing. You can calculate the lead. Let us calculate the lead by how much percentage we are leading. This is next month sales value. So again, it would be a next month sales value minus sales value divided by sales value. Okay. Lead. Okay. So this is a lead percentage that we have calculated. Getting, guys? This is the lead percentage, but we are leading by 10% in next month. In next month we are not leading minus 4%. So this is the concept of lead and lag. So till now what we have read? We read about the window functions. We learned about the window functions can accommodate aggregate functions and window functions both. So what aggregate functions we read? Max, min, average, sum, count. So we read all those things. We also read about the window functions. We learned about the rank, dance rank, difference between rank and dance rank. Then we saw what is percent rank. Then we saw row numbers, concept of row numbers, then first value and last value. Then we learned about lag and lead. We also learned about the another concept, that is CTEs, common table expressions. In that we also learned about what is difference between CTEs versus views. Okay, are we clear with this? Let us learn the last concept for today's session. Since we have 20 minutes left, let us understand the concept of frames. What are frames? So frames are nothing but the operations that we are applying within the partition. Okay. Let us take some examples. Let's start from city sales. Okay. Let us take some good examples. Let's start from pivot stock data. Underscore data. We have this. Okay, great. So let us first calculate a running total. Let us first try to calculate a running total. How to calculate the running totals? So let's say this is my table. This is my table. Inside this table, I want to calculate a running total. Running total. Okay. Let us forget the month. Let us forget the month. So let's say I have city and I have sold. That's it. I have these two columns and I want to calculate a running total. So how to calculate that? So to calculate those running total, what you will do, you have a keyword. You have keyword rows unbounded preceding. This is a keyword. Okay. This is a keyword rows unbounded preceding. Okay. So what you are telling, boss, you are telling select the city, select the sold quantity within each city. I want to calculate the running total, that is sum of sold quantities. Okay. In over clause, you can tell that okay, I want to order by, let us order by city, order by city. Now I want to calculate this total sum based on rows unbounded preceding. What it will do, let's say our first record is Pune and then we have 300. Then it will see that okay, the previous record we don't have anything, so the output would be 300. Running total would be 300. Let's say again the second record is Pune. It will take, let's say sold quantity is 200, so it will go to all the previous rows above this. It will see what is the sold quantity. So above this is our current row, this is our previous row, so it will just calculate the total of both this, because we have given a keyword rows unbounded preceding, and on that unbounded preceding you want to apply the sum, so you will get output as 500. Okay, when I'll get a city as Raipur and let's say it is 300, so again it will see that okay, I want to calculate a sum. Okay, and you need to order by city. Okay, then there is a keyword rows unbounded preceding. Okay, so take all the preceding rows and calculate the sum over this, so that's where you would get output as 800. Okay, let us rename this column as running total from sales. Okay, running total from sales. Unknown column city. Why am I doing something wrong? Select city, sold. Unknown column city in a field list. Okay, because from sales, city underscore sales, my bad. So see, here I am getting a running total. Here I am getting a running total. See, 300, then 5 plus 3, 800. 800 plus 200 is 1000. 1000 plus 300 is 1300. 1300 plus 200 is 1500. 1500 is okay. So this was a very basic problem statement where we are calculating the running total. We have not introduced the frames. Okay, so the combination of window function, partition, and this keyword can lead you to the concept of frame. So now I want a running total. Okay, we want a running total for each month. Running total for each month. Okay, select star from city underscore sales. So you would see now I want a running total for each month. I want, okay, this is my first month. The running total is 300 plus 200 is 500. Okay, you can do it. You can do it. Let's say we want a running total for each month, then we'll do running total by city. Okay, so let's say again we have second month. I want total as 500. Total would be 500. If you see it is a fourth month, total would be 300. Okay, then here it should be 500. Let us see that. Take the same query, let us copy paste running total for each month. That is, we should do partition by month. Okay, and order by city. So that's where you would see Pune is coming first, then Raipur. First Pune will come, then Raipur will come. So see, a running total is coming for each month. Let me write month also. Let us select month. So see, for month 1 it is 300, then 300 plus 200 is 500. Okay, for month 2 we have only one single value 500, so we got output as 500. For month 4 200 is 200 here, 200 plus 100 300 is here. Okay, we can also do a running total based on a city. Let us calculate the running total based on a city. We want a running total for each city. That's where you can do partition by city. That's it. Okay, so see, for Pune, the running total it is calculating. 300 plus 500 is 800, 800 plus 200 is 1000, 1000 plus 300 is 1300. The moment the city got changed, 200, 200 plus 100 is 300, 300 plus 200 is 500. Okay. If you got this, let us move on to the another concept. If you have ever seen about the stock market, in the stock market they always calculate the moving averages. The concept of moving averages. What is that concept? Okay, let me just take, let's say you have a stock of Infosys. Okay, Infosys, and day 1 the market price is, the share price is 100. Day 2 the share price is, let's say, 110. Day 3 the share price is 105. Day 4 the share price is, let's say, 110, and day 5 the share price is 115. Day 6 the share price is 120. Okay, and day 7, last one, the share price again fall down to 100. So what is the moving average? So let's say I want to calculate the moving average of 2. Moving average of 2. What is the moving average of 2? So first, here I have only this current row. Okay, I don't have the previous. So moving average is 100. Okay, then in this second row you would see second row. Let me arrange it. So here we want a moving average of maximum 2 rows. So 110 plus 100, the moving average would be 105. Okay, now I got 105. Day 3, what is my moving average? I am calculating moving average of 2. 105 plus 110, so that is somewhere around 107.5. For example, I might be wrong, okay, in the calculation. Then third, day 4, 110 plus 115, moving average is same, 107.5, because we are calculating moving average of 2. If we calculate moving average of 3, then we will take 3 rows. Okay, again 115 plus 125 divided by 2, then it is 112.5. Then 120 plus 115 is 135. 135 is 117.5. And 120 plus 100, 130, 130, 115. Okay, so these are the moving averages. In similar manner, we want to calculate the moving average of the stocks. So I'll do select star from pivot stock data. Okay, and I want to calculate for stock name and its close price. So I have this stock data and I want to calculate a moving average. What is the moving average? Daily, year, month. So see, you would see there is a year, month. So I want to calculate the daily moving averages. Okay. So how do you calculate this? So let us first calculate moving average of 3. Moving average of 3. So I have average of close price. I want to calculate the average of close price over partition by stock name, because I want for each stock that should be different. Okay, then I would use rows. So see the keyword between 2 and two preceding. So I want two preceding row and current row. So that is 3 rows. So see, if I'm here, so before that 2 preceding and the current row. So that is moving average of 3. If I'm here, so current row is this, the selected one, and previous 2 rows, I have only 1 row. So it will take the average of this. I'm here, this is current row and preceding 2 rows. I'm here, it is the current row and preceding 2 rows. Okay. As, as moving average of 3. It is moving average of 3 from pivot stock data. Partition spelling is wrong. Okay, that's it. So see, we are calculating the moving average of 3. You can try to calculate 63.05. It is same. If you calculate the average of these two, you will get this. Okay, if you calculate the average of these 3, you will get this. If you are here, you calculate average of these 3, you will get 3. If you are here, you can calculate the average of these 3, you will get this. Okay, this is moving average of 3. If I want to calculate moving average of 5, 10, 20, so that's where you could give us moving average of 5. 5 is, let's say, 4 preceding row and the current row, that is 5. Okay, that's a moving average of 10 and 20. We want to calculate the moving average of 10, moving average of 20 rows. So 10 would be 9 preceding rows and 1 current row, 19 preceding rows and 1 current row. See, these are the moving averages. How the averages are moving. So you would see that after the 4th row, the average will get changed. Okay, drastically it will get changed. So this is the concept of the moving averages. You could also write, so let's say if you don't want to include the current row, if you don't want to include the current row, I can write moving average 3 excluding current row. So you could also write select name, year, month, close, average of close over partition by name. Okay, and if I go down, so you would see the average would change as the stock name changes. So see, it is 2, so average is also changing because we are doing partition by stock name. Okay, and you would do rows 3 preceding, preceding. That's it. You are not writing current row, moving average of 3. Okay, rows average of this, close this, comma, from pivot stock data. What is the error? Spelling of pivot is wrong. It is pivot stock data. Okay, so see, now it is calculating the average of these 3. Okay, previous 2. If you see this, the average is same. Now it will calculate the average of previous 2. You will get this. Okay, I am here. Then it will calculate the average of previous all the 3. So this way you could also write this rows 3 preceding, total 3 preceding rows it should take. You could do total 2 preceding rows if you want. So it will calculate a total 2 preceding rows, whatever is your logic. Okay, so guys, this is all about the moving average. If you are analyzing the stock market data set, it is very much helpful. The main moving averages that we see is 30, moving average of 30, moving average of 50. Okay, and that's where it is very important. And we know that when the moving average 30 crosses the moving average 50, the stock will go up. If moving average 50 crosses moving average 30, the stock will go down. So that is one of the analysis that we do in the stock markets. So I think guys, that's it for today's session. I hope we have covered the most of the things, and in next session we will cover the remaining topics. So I hope you enjoyed today's session and you have learned something new. So stay tuned and be ready for the next session where we would be studying about the pivots. We would be studying about the cursors. and we would be studying about how to create the dynamic programming in the SQL. So thank you all. Have a great day. Take care. Bye bye.